sunrise, sunset. Today is the best one yet. Crab pot, horsefly, not a cloud in the southern sky. Starry night, crescent moon, and palmetto tree. I'm so high, you see, on the low country, salt and sea hospitality. I'm so high on the low country.
Guys, welcome to Front Porch Forum. We're here with William Cubbage of Energy One and Jamie Kay of the Elm Energy Group. We're here today to talk about thermal envelopes, thermal barriers, insulation types, insulation options, how that varies between different parts of a house, be it the foundation, exterior walls, the roof. These two gentlemen I have relied on for quite a number of years. Going back sometime, I was introduced first to Jamie through a local architect who, after you spoke with Mr. William Court, he actually sent me a note and said, you guys kind of speak the same language. I recommend that you reach out to Jamie, and gosh, that was probably 7 or 8 years ago.
Yeah, wow.
And at that time, I was involved with the United States Green Building Council, heavily involved in the Savannah chapter, pursuing LEED accreditation, which has really gone to the wayside over the past couple of years. You don't hear as much of that. It's funny, it was a big thing during the downturn of the economy, but things started doing well again, and that's no longer a big deal. But it was a great learning experience for all of us, because I think we took some of the best practices, techniques of that, and even though these houses technically aren't LEED accredited for the most part,
Probably being scoot in.
I bet, without the documentation.
Mm-hmm.
So, and Energy One has been, my go-to choice for insulation needs, and in a lot of instances we work together for waterproofing needs. But your expertise and focus on advancements within the industry and staying current with things has been a great resource for me. So I certainly try to do my homework as a builder and general contractor, but I've heard it said before that there used to be builders back when homes were simple. They're no longer simple. For one person to be able to understand the magnitude of every scope that we have to incorporate in the houses that are being built today, it's really not feasible. However, for one person to focus on a particular scope is certainly feasible, and surrounding yourself with people that know what they're talking about is premier. So I'm going to give you guys an opportunity just to say a little bit about your company, and then we'll jump right in.
Sure.
Mr. Cubbage?
Well, thank you for the introduction. Again, my name is William Cubbage. I'm Vice President of Sales for Energy One America. And just like Josh said, over the past 8 years, we have kind of learned the progression of respecting thermal envelope and the different products that come up every year that we can use in better homes, and starting with the spray foam envelope and looking into the different aspects that we can add to build a better home. And Josh has been a great partner of ours to help us grow and to find these different products that are going to better us as a company, better him as a builder, and then ultimately give a better product to the homeowner.
Absolutely.
Yeah, so it's been a good experience.
Let everybody sleep at night.
Yeah, exactly. And then hopefully keep those
Comfortably.
comfortably with as energy bills low as they can.
You're talking about the client. I'm talking about me.
Yeah.
Let us sleep at night.
Well,
Mr.
if
J.
they're sleeping good at night, you're sleeping good at night.
That's exactly right. Yes.
Yeah, I'm Jamie with Elm Energy Group. We're a local building science company focusing on anything from the indoor environment, doing HVAC design, lots of testing. We've been testing behind Josh's homes after they get foamed for about 8 years since the very beginning. And we just focus on trying to help build a healthier home.
But yeah, you just touched on planning and also the res checks, the manual J's, the manual S's, the planning for the HVAC equipment on the front end, orientation of the house. There's so much more that goes into what you provide other than blower door tests. So
Right.
I think
you.
oftentimes it's considered, you guys are considered as the ones to come in and point out the problems. That's not the case. Working together from the beginning can make sure that everyone's starting off in the right direction and looking out for possible issues.
Yeah.
So in a lot of instances, you're one of the first persons to receive a set of plans, that I distribute when it's time to go to permit, for those manual J's, manual S's, and res checks that are necessary for us to pull a permit. And for those that aren't familiar with that, in layman's terms, the best I can describe it, what that does is it tells the HVAC contractor, it tells the mechanical engineer what type of equipment, what size equipment needs to go into the home from a energy efficient standpoint and an energy code standpoint, depending on the locations of the fenestration or windows, the level of U value within the windows surrounding the house. All of those things are taken into consideration before the house ever goes up, before a builder's ever able to receive a building permit. So probably something that's often overseen or not even thought about is how much pre-planning has to go in to the design of a house before it gets constructed. So
More so now than ever.
more so now than ever, and it increases all the time. So,
And coming from a trade partner, that's essential for me to plan the best way, and for those discussions to be happening at the planning stage allows everyone to know what's going on from the time that permit goes to the time to insulate the house. So there's no guessing. There's no what are we going to do at this point. That planning process is essential for us to do the best job we can do, and I think it's the best thing you can do.
so with that being said, we're here on property. This is as I've said before, this is a home that Beth and I are building for ourselves, and it gives us an opportunity to dive deep into aspects of this, and for me to be able to talk about things that I would never talk about as it relates to a client's homes. I have these same thoughts and conversations and whatnot behind the scenes, but I would never put it out there just out of respect for our clients. But here we can talk about, the possibility of me considering something that, me considering all the options and talking through them. So from the beginning with this house, as with all of our houses, I look at the foundation. I look at, from the ground up. You should build a good foundation, and that's the first place, the only place to start, right? So here, this particular home, I elected to go with a block foundation, a isolated pier foundation to minimize the impact on this piece of property. There's homes that have been built for ages on the similar concept. It's not done a lot nowadays. Most of our footings, even in a piered system, are going to be continual. I did want to have isolated pier footings, again, to minimize the amount of concrete trucks and traffic back in this area, as well as the root structures in the surrounding environment.
So you don't have them all tied in to each other?
They're not tied in. These are all true isolated pier footings.
Awesome.
So,
Yeah.
very uncommon. But I spoke with Whitaker Laboratories, who does a lot, if not the majority, of all of our testing within the area. And having built up and down the river here, predominantly over in Palmetto Bluff or Colleton, being somewhat familiar with the soil structures and different elevations, different areas, I felt confident given what I'd seen here. And Mr. Rick Strauss was nice enough to come out here, and we did a couple of hand bore tests. And based on what he's seen, he's certainly seen a lot more properties than I. He said, "Josh, you're fine. Don't worry about it." Typically, in most cases, I would actually recommend that a client enlist geotechnical services, where you have a truck come out, a well drilling truck, and they core, and they'll give you a complete strata analysis of the different layers. I've read enough of them and am familiar enough with them, with the type of foundation and structure that we're building here. Guys, if we see a little bit of settlement here, a 1/4 inch to a 1/2 inch, which is predominantly what you see in these reports, I think we'll be okay. And again, that's me and my house. So for the first topic, why don't we start on this type of foundation that we're dealing with here? Predominantly in the Low Country, I think we see across the board a monolithic foundation. Certainly, the majority of, say, production homes, maintaining the code required 6 to 8 inches of exposed foundation is probably the predominant foundation. You don't have to worry about any type of heat gain or loss or whatnot. We don't have a freeze line within this area. So all of that's off the table. You don't have to worry about it. Here, I wanted to elevate this house for a couple of reasons. One, the goal of this home is to look as though it was built in the 1930s and added on over the years. You wouldn't have done that foundation in the 1930s. They didn't have slabs. They didn't have concrete trucks.
Yeah.
So or maybe they did have concrete trucks. But anyway, we did want to elevate the house. It's on piers. So what are you going to do with the piers? A couple options. Enclose it. Chose not to in a traditional method. You could do that with formed walls, poured concrete. You could do it with continual block walls. Didn't want to do that. So we did the piers. I'm going to, as we talked about before, take 4x8 sheets of a PVC product that is obviously rot resistant and insect resistant, apply it to the backside of my piers, most of which are 12x12 piers. I'll ram set it, I'll seal it, ram set it, and that will serve as our foundation wall. Once that's in place, I've already gone, before we put our decking down, I raked the floor system. I've cleaned everything out of there. It's a nice environment. At a minimum, you got about 36 inches of headroom. I'll call William and I'll ask William to come in and from that point encapsulate the foundation in its entirety and go around with a rigid foam board, 2 inches thick, and the rim band. So the foam board goes, better yet, why don't you walk us through your recommendation?
As an insulator in the Southeast, especially where we are, you really have to take into consideration how a crawl space is going to get insulated. With this one specifically, we're built up. The way it is right now, it's technically ventilated, but we're going to seal it off. The great part about a sealed crawl space is it allows you, the homeowner, to control what's under the home. A lot of ventilated crawl spaces, the way they're set up right now, you almost have no control. You've got water coming under the house. You've got moisture issues. You've got floor systems expanding and contracting because you're not controlling the moisture drive under the house.
Pests.
What's that?
Pests.
Yeah, pests.
Yeah.
The list goes on. So in an area that we live, this allows you to have some control. So fortunately, again, with pre-planning like we've done it here, what we can do is we can put down a very strong liner acting as the moisture barrier on the bottom of the crawl space, the dirt floor. That's going to allow for any moisture that occurs under in the dirt itself to not transfer to the floor system. We're going to take that liner and we're going to run it up the sidewalls. And what we're going to do is run the sidewall up and then put our insulating foam board over the liner to create one monolithic path there. We're going to run that up, and as that foam board hits the bottom of the rim band, we are going to run a bead of caulk on the sill plate, create an air seal right there, which can be, as Jamie will tell you, can be a very leaky area in the crawl space. Then what we're going to do is we're going to picture frame the rim band. We want to air seal the rim band, but we don't want to provide a permanent source of insulation. We want to provide a insulating material that can be removed to be inspected for any type of termite activity. And then that's pretty much it. So that's going to be the whole composition. Maybe, Jamie, you want to touch a little bit about all the air seal qualities and what else we'd like to see right there?
I mean, so, the closed crawl space is often called the clean crawl space because of just that nature, how clean it is. And it's known that houses work like chimneys. And on houses that are built up like this, 40% of the air in houses come from crawl spaces. So having this clean crawl space is paramount. But as these houses work, we want to seal up everything, preventing the points of entry around that crawl space from providing that effect, that chimney effect.
I think one of the best things about a sealed crawl space is, conversely, if it is a ventilated crawl space, we want to have that thermal line, be it your floor joist, be at the bottom. When we're doing the opposite, we're taking that thermal line and we're running it on the sidewalls, and it allows for that floor system to not have to be insulated.
True.
The best part about that is whether you're using a foam or a fiberglass product, it's open for inspection. That is one of the hardest places to run wires, to find plumbing, to find those things that need to get fixed. And I can't think of a better reason not to have something there, especially with all the things you have to put down there.
So a couple of things. You mentioned inspection and the removable insulation. A lot of people probably don't realize that in order to maintain your termite bond, you are going to have to get an inspection, be it whomever your termite bond provider is. They're going to come out to the house once a year, right?
Yep.
And they're going to go underneath the house in this case, or walk around the perimeter in the case of a turned down monolithic. And they're looking for the little highways or the tubes that termites create. We've got a tree on the back left of this home that I've actually treated. When we were clearing the property, we noticed there was a ton of termites already in a dead portion of a live oak, and we treated that tree already. So
They were getting excited about what
So
they were
they were-
seeing here.
they were ready to dig
Licking their
in.
lips.
Yeah, man.
Yeah.
Which is, a reason why we've got dunnage underneath all of our framing materials, and because they are aggressive here. I mean, I've seen framing materials on a job site be infested by termites just because they've left in on ground contact. So that's important.
We've definitely evolved, like you were speaking about, over these many years doing this in this area, where you used to foam that whole wall all the way over the rim bands, and what was happening with those termites were doing the same thing they did in that fake stucco and making it behind it, hiding in this foam. And who cares how energy efficient you are if you have to rip it all down to fix it.
Exactly. Or create a pathway in which something's going to be able to get up there and damage your structure. Everyone, we've seen, the good, the bad, and the ugly. And the ugly when it comes to termite damage is tearing off the backside of a house and $100,000 plus, insurance repair jobs.
Right.
So
Right.
no one
Respect them.
We don't want that work, and we certainly don't want to have that happen to any of our homes.
Yeah.
So, furthermore, as far as the foundation is concerned, the sealed crawl space is my recommended crawl space if anyone comes to me and says, hey Josh, how do you build in the low country? We get that question a lot when we're dealing with out-of-town architects. I've received multiple sets of plans from architects that are designed in a different manner because it's designed how one would build a home in the Northeast. And I'm happy to say that in a lot of instances, I'm able to sit down with a client and with an architect and say, if this were my home, this is what I would do.
I would not build the basement.
Right.
Yeah, because you're going to have water.
And build a sealed crawl space. If you can control it, if you can encapsulate it, then you're able to maintain the moisture content, the humidity level. You're able to take care of it. There's nothing wrong with a turned down monolithic slab. We build a lot of them.
Sure.
They're elevated anywhere from 3 foot to 4 or 5 feet. The only issue there is that you're not able to access your plumbing or anything underneath the house.
Alterations in the future. Mm-hmm.
There should never be anything that happens, but God forbid something does, and you have a damaged plumbing line, waste line, water line, you can't get to it. And trying to locate it, trying to find it can be a big issue. I've seen some tough things.
I think that's a kind of a benefit too of not foaming a floor system and doing the walls is everything you have that you may not remodel so soon, but we do often do it, every decade or so. You got that versatility still. You don't have foam covering everything and good accessibility.
Even though we're not remodeling here, working with my cabinet provider and working with my plumber, we're going to be doing a galley sink at the kitchen island. It's a 5-foot long sink. It has a center drain. 5 foot taken out of a kitchen island is a lot of space. So being able to maximize the usable space in that cabinet, I want to minimize my area taken up by my waistline. So as I work through the cabinet design, I can leave my drain line and my water lines in the crawl space. If this weren't the case and I was doing a monolithic slab, I would have had to finalize that island design and bring up that plumbing in a location that I may not be ready to make that decision on.
crossing your fingers on, sure.
Or coming back and chipping up concrete.
Yeah, right, moving. Yeah,
Now, when you have a sleeper system, that's a little bit different, but not when it comes to a drain line.
yeah.
So it does provide other benefits. And that's ultimately the reason why we decided for this type of foundation, right? So that was the driving factor in the type of foundation. Now, then the attention turns to how do we insulate it? How do we take care of it? We've kind of walked through that, what we feel as best practices, and I think that we all agree to those best practices. We will provide dehumidification underneath there. And Jamie, you've got some options and some recommendations as far as monitoring that.
Yeah. Well, today that you can get these little remote monitors that you don't have to be down there all the time. They communicate with your smartphones. You can set relative humidity settings so it can send you alerts. So, if it's your home, you may geek out enough to go underneath there often. But if not, you can, just look on your phone and see what it is.
Sure.
I also, with dehumidification underneath there, do recommend, fans, things to help move air around underneath there and let the whole thing kind of work together as one.
And we do install a lot of fans because one dehumidifier is going to take care of, say a 3,000 square, not that this house has that, but say a 3,000, 4,000 square foot area.
Especially if you have a U-shaped crawl space where you've got little pockets and that air is not going to be able to push around a corner.
Get that area.
Yeah, a typical square might be a little bit better if you can just centralize it, but they look at the CFM rating, and if it's in between 1 to 2 DHUs, we'll do a circulating fan just to try to push it around a little bit. Now, correct me if I'm wrong, but I don't believe that dehumidification is code required.
Well, no, it is. You have to have either 2 CFM per 100 square foot. If you do a closed crawl space, you have to provide 2 CFM per 100 square foot, or some means of dehumidification underneath there. And
So it's not just where the insulation line stops, where if you have it on your walls, you have to, no matter what.
a non-vented crawl
some
space
type of-
has to have something like that.
The wall cavity we consider from an insulator is probably the third most important from a thermal loss standpoint. Jamie could probably touch on this, but in an envelope like this where we've got an elevated crawl space, we consider the roof to be the most beneficial from a thermal loss standpoint. We want to take care of the roof first, then we want to look at the crawl space. Then we consider the walls to probably be your third most vulnerable of the three from a thermal loss standpoint. So if I agree that open cell foam is a great resource for insulating the wall, but if I had to rank them, it's probably the third most important and where your thermal loss is going to be exchanged. So and maybe in a home where you're maybe not have the budget to do spray foam everywhere, we always encourage you to go to the roof first, then look at how you're going to insulate the crawl space, and then look at how a wall is insulated. But in this specific case, I think open cell is a great product for your walls.
Jamie, what do you think?
I'm not product biased. I think our
Understand.
values are our values. So spray foam or fiberglass or closed cell foam, as long as you're getting the same R value. And I think that when we start looking at the way that a lot of fiberglass gets put in,
Sure.
it's rushed and it doesn't give you the performance that I think you can get from a spray applied product.
One of the main reasons I lean towards open cell is the fact that I feel like it creates a quieter house. It seals a lot of air gaps along in the process.
The openness of the open cell foam, that's what does the sound attenuation.
Sure.
The airspace.
And when you have a home that has impact rated windows with open cell foam in the walls and even in the ceilings, I think that's about as quiet a home as you're going to walk into. So, I don't think you can go wrong putting open cell in the walls. I don't know if you guys would agree with that.
I think Jamie would agree that everything is in the application.
Right.
So, same thing with stucco, same thing with siding, roofing. It's all about the installation.
Yeah.
So,
Yeah, I don't
you
see
can have
that.
issues, but
I don't see downsides though in walls with open cell.
And certainly, I know that a lot of people and a lot of builders in the area, from a value engineering standpoint, will put bad insulation in the walls, open cell in the roof, and it's that combination has been done a ton. And personally, as a builder, I wouldn't say anything negative about it. Our choice here and our recommendation to our clients is though to go with open cell. Now, so not a whole lot of time needed to be spent there other than making sure obviously in the walls that we seal around our windows and doors very well, any exterior penetrations. And we'll use a closed cell minimal expanding foam for that, right?
Yeah, or caulking or whatever you need to do.
And also caulking our sill plates, our top plates, corners, we can talk about some other things, as far as what we'll do after the fact and other opportunities to increase that. But jumping up to the underside, or let's just talk about the roof in general, the attic space in general. Years ago you would see blown insulation in the majority of homes on top of the drywall that was insulated and installed after the fact. Certainly with the majority of production
With a
homes,
vented roof.
vented soffits, vented ridge, and that's the customary way to build homes in the majority of the country. Along comes closed cell foam insulation, and now we're taking that thermal barrier to the underside of the roof. Even before that, we were able to accomplish it with other products.
Correct. And when you're changing the science of an attic assembly from a vented to a non-vented, there's essential things that have to be done. And as an insulator in the Southeast, the question that we hear more than anything, and that Jamie hears too, is, isn't a house supposed to breathe? And and Jamie will touch on this, but we're raising that thermal envelope from your drywall line on your second floor or whatever floor, and we're raising it to your peak of your roof. We're sealing off your ridge vent and your soffit vents, and that spray foam is drastically decreasing the thermal load on that roof deck. So in a summer where you have 120 degrees can be achieved in the middle of July in a vented attic space, you're only going to experience 15 to 18 degrees different from the conditioned side, your highest condition level and your attic. We want to touch on that when we go from there. On
The water behind us.
I wish we lived in an area where in the middle of July you could open up your back sliders and get some fresh air, but you're going to get some mosquitoes and a lot of humidity.
That time frame is small here.
And we'll talk more about that in future episodes, probably when we circle back after insulation, as to what we're doing to control the indoor air quality, to control that the makeup air that comes into the house. But the roof, I think, is a point of debate here between the three of us probably. I talked to you, Jamie, and you've told me your recommendation, so I'm just going to let you say what your thoughts are as far as insulating the underside of the roof.
Oh, I'm definitely a fan of a non-vented assembly, a sealed assembly, and you could use open cell, closed cell. You can use other products up there too. Some of them are just more difficult to achieve. When we're talking about the difference between maybe open cell and closed cell, maybe you're talking about that.
Yeah.
We have to work harder with open cell
Sure.
to manage the moisture that's up there. There's been studies done where it shows the vapor and the humidity and the warm, moist air that rises up in houses wets the wood up underneath our roof deck. And now the code requires us to super seal our ductwork, and so we're not getting a lot of air mixing and movement up there. And so open cell, when the house is not effectively sealed,
Yes.
it can definitely cause some challenges in humidity up in the attic.
Especially when it's that July day, and say it's upper 80s and not 105-degree heat index, and you want to open up that big slider on the back, you rush in a ton of air that has a 90% humidity level.
Yeah.
Now that moisture's in the house,
Wet hair.
wet as can be, and it's finding dew points.
And it's doing the stack effect. It's doing what air does.
Sure.
It doesn't have a port of exit, that ridge vent up at the top, and so it captures itself up there. And due to the open cell nature, it goes through into the woods behind it. And that's one of the reasons, if you're going to use open cell, you have to do something that we talked about. How the code says in the crawl spaces, we need to have a couple of CFM of air per 100 square feet to prevent staleness and prevent humidity issues. They haven't wised up enough to get us up into the attics and make that, but that's what you have to do with open cell more so than with a closed cell product up there.
Which is what you would recommend.
It's a better product. It gives you some uplift and shear strength. We're already building pretty tight and overly engineered structures anyway, but it still does add that aspect of it. And and then you just don't have any of that potential to have that moisture storage there. There's a lot more resiliency there.
So what do you think about that, William?
I agree with the aspects of open cell. All those are true. The application of closed cell provides just as many hindrances to homeowners that open cell factor has. Removal is very difficult. Inspections of the underside of the roof are difficult as well. A lot of times, if you have closed cell in the roof and a repair of a large scale were to happen, a lot of homeowners actually have to come from the exterior of the roof deck and remove metal and sheathing and repair from the top side. So
Going number 2, but
Not
Matt
for smells.
fans,
Not for smells.
not for smells.
Yeah, the colloquial fart fan, right?
Exactly.
You know?
Majority of the population probably thinks that's it. It's there to get the smell out.
Get all that moisture out.
It's there to get the moisture out. So we're taking that moisture out of the bath, and we are exiting it to the exterior, but the air that we're bringing in is being mixed with indoor air,
Climatized, yeah.
climatized, knock the humidity down, and then it's being dropped into a return that then goes through the HVAC system, where it's further acclimated and dispersed throughout the air, out the house.
It's kind of like we don't want to have that big slider open in July but that kind of gives you the ability to have a window open all year long because it's always bringing fresh air. Every time you use the bathroom, you're getting this fresh air into your house.
And we'll go a step further to put a
Built-in.
bath fan on a timer so that when you go into the bathroom and you turn the light on, and we do this a lot where we make it idiot proof. You go in, you turn the light on, and that switch may look like a regular switch, but internally you are able to control its programming so that even after you turn the light off, that fan runs for another 30 minutes. You don't even have to think about it. It's not the switch that gives you the minute options, it's just a regular switch.
They're editing this. You built for a lot of idiots. So you
And utilized to offset the negative pressure created.
instead of bringing it down the soot from the chimney.
We finished a house for a client recently, and this was a large home. And you would think maybe it would have enough air to be able to compensate for these 1,500 CFM hoods. Our client wanted to see the operation of their fireplace. And obviously, and I walked over and I turned the fireplace on. And what I'll do is I'll take a cigarette lighter and hold it right there in front of the fireplace on the vertical plane in front of the firebox. And when the fire is burning and the outdoor air is on, you'll see that flame go to the chimney. Now this was a great room, fully expansive, great room, dining room, kitchen, and they have this huge top of the line blower. I went over there and kicked it on high. I walked back to the kitchen or to the chimney fireplace, held that lighter up, and it's blowing in. I went over to a door and I explained, this is going to happen, but you need to know this, and this is all you do. You either crack a window. I opened that door and went back with the lighter, and now it's drawing again.
Right.
Oftentimes, I feel like it's thought that we're supposed to be some type of magicians that just make things act
Fight
against
physics?
the force of nature.
Yeah,
But no,
yeah.
it's not. But we need to know what's happening and accommodate it, and also educate our clients. So.
Yeah, tightly sealed homes. I mean, that's what you're building. I mean, that's what he's providing, tightly sealed homes. And, difference in coolers today is profound.
Yeah, we're building
Better coolers.
Yeti cooler
That's
homes.
right. That's right. And what's the difference? The R value is not that different
Yeah.
from an igloo to a Yeti.
Right.
The difference is that seal. was after Hurricane Matthew.
Right.
I went to a house in Moss Creek in April. We had the hurricane in October. I went to it in April. And there was a section of roof down low below where they patched. They were about to touch up with all the open cell foam. They had pulled sections out and replaced the roof. I pulled a section of open cell foam out, grabbed it, and was able to squeeze it 6 months later with water sitting in it. And it changed my mind about, it is a sponge, but if the sponge is not continually provided water, it might not dry out
If it's not overly saturated,
in that application up in the upper attic where there's not drying potential. Had she had a dehumidifier or things like that, it may have been a non-issue. So
Right.
so a lot of it comes down to acts of nature and what kind of control you have there.
So I think that, in general, we agree on the foundation that we have here. We're going with a sealed, dehumidified foundation. Our walls, obviously there are options. Multiple of them could certainly suffice. We're going to go open cell in the walls. Roof, I may consider closed cell. But as of right now, we're leaning towards open cell. That's the thermal envelope here. Our next steps, so we're going to start mechanical rough-in here shortly. Is there anything else that we should consider, William?
Once a house is spray foamed and the air seal is starting to, you've air sealed the windows and doors and you've spray foamed, there is a third resource that can look at basically air sealing a lot of the areas that physically can't be sealed. There's a product called Aero Barrier that works in conjunction with a blower door test, and it allows for a specific type of resin that can be shot through the inside of the house and seal cracks. I want to say as small as is it a quarter inch?
As large as
As large
5/8.
as large as 5/8.
Larger than I was expecting.
And it's going to seal all that up while the house is pressurized, and then it can even allow you to get to a desired air change. Basically, set it as a target, and then once that desired air change has occurred, it will stop. So if like in this process where you've got your mechanicals discussed, you've got your thermal envelope discussed, if you've got an air change that you want to achieve, this is a great resource to say, boom, I know I'm going to get this 1.5 to 2.5 air change, and that's the resource that's going to guarantee that it gets there.
Pieces of towel to show air movement, find air movement. Then you can touch it up right then before the sheetrock gets in. You've got your cooler. You've finished your cooler. You've tested your cooler. You know what you got. You're going to cover it up, and that's something that you just don't touch for the eternity of the house.
And I think you've done that for every home that we've built as long as you and I have known each other.
Absolutely.
So we'll certainly do that. And at that point, once we see what that air exchange is, and after you've done the touch-up, obviously if there's an area that gets missed, William, you're going to be right there to help us take care of anything. But after we've gotten the house nailed down, I'm interested in seeing what the air exchange is.
Mm-hmm.
Some of the data that I've read regarding zip wall, which is the exterior weather-resistant barrier we're using as opposed to a house wrap, is that this can get a home on the verge of you think the air barrier?
Aero Barrier, yep.
The aero barrier, how much further you think that can take us? A little experiment that I want to see here is, given the fact we're handling the indoor air quality from a humidity standpoint, I want to make this house as tight as we possibly can.
You got that ability. Once you got the ERV, once you got it ventilated right, build it tight.
So that's the goal. Guys, I want to thank you for the opportunity to sit here with you today and have this conversation.
Thank you.
Anything else you'd like to add?
Let's get it insulated.
Cheers. First edition Front Porch Forum.
Cheers.
Sunset,
Here's to good homes.
sunrise, dunes whisper a lullaby, red drum, stray cat, lemon sun and a pine straw hat, secret spot in the shade of a canopy. I'm so high, you see, on the low country, salt and sea hospitality. I'm so high on the low country. I'm so high on